Hello, my dear students. Today we are going to continue our discussion on chapter 2, which is chemical analysis. We are going to continue our discussion on identification of acidic radicals. We are going to discuss the anions of sulfuric acid group and barium chloride group. So let us start. My dear students, today we are going to discuss the anions of concentrated sulfuric acid. It includes the following anions. Chloride ion has chemical symbol Cl-1. Bromide ion has chemical symbol Br-1. Iodide ion I-1. And nitrate radical NO3-1. My dear students, we have give reason in this point. The sulfuric acid is used to detect the above anions. The reason for that, because the sulfuric acid is more stable than the acids of these anions, so when it reacts with their salts, it releases their less stable acids in form of gas that can be detected by suitable test. Now we are going to make the detection of the first anion, which is chloride ion. The main test for it: the unknown solid salt plus concentrated sulfuric acid plus heat if needed. The produced gas and its test is the evolution of the colorless hydrogen chloride gas that gives white fumes of ammonium chloride with a paper wet with ammonia solution, as the following animation show. As shown on the screen, on adding sulfuric acid on the solid salt, here hydrogen chloride gas is produced that with ammonia solution gives white fumes of ammonium chloride as shown on the screen. Here is the equation of the reaction: 2NaCl plus H2SO4 concentrated and heat, it gives sodium sulfate plus hydrogen chloride gas. Then hydrogen chloride gas, when reacts with ammonia gas or ammonia solution, it gives ammonium chloride fumes. Now we are going to discuss the confirmatory test. The salt solution plus silver nitrate solution, the produced precipitate is white precipitate of silver chloride that turns violet in sunlight, as the following animation show. Now, my dear student, we are going to add silver nitrate solution on sodium chloride solution. We are going to show the reaction product, which is white precipitate of silver chloride that will be formed in the tube, as shown now on the screen. Now the equation of the reaction: sodium chloride plus silver nitrate, it gives sodium nitrate and silver chloride, which is the white precipitate. Now we are going to discuss the bromide ion. Here the main test is the unknown solid salt plus concentrated sulfuric acid and plus heat if needed. Here is the produced gas. Here is the evolution of colorless hydrogen bromide gas that is oxidized partially by sulfuric acid, giving orange-red fumes of bromine that turns paper wet with starch into yellow. As the equation proceeds on the screen, sodium bromide plus sulfuric acid, it gives sodium sulfate and hydrogen bromide gas. This hydrogen bromide gas is oxidized by sulfuric acid, giving bromine gas, and sulfur dioxide gas and water is produced. Here the confirmatory test for bromide ion: the salt solution plus silver nitrate, the produced gas is white yellow precipitate of silver bromide, which is formed and darkened when exposed in sunlight. Here, this slightly soluble in ammonia solution. As the equation proceeds, sodium bromide plus silver nitrate, it gives sodium nitrate and silver bromide will be precipitate. Now we are going to discuss the iodide ion as shown on screen I-1. The main test is the unknown solid salt plus concentrated sulfuric acid. Here the produced gas is hydrogen iodide gas that is oxidized partially by sulphuric acid giving violet fumes of iodine that turns paper wet with starch into blue. As the equation proceeds on the screen, potassium iodide plus sulphuric acid by concentrated and heat sulphuric acid gives potassium sulfate and hydrogen iodide gas that is oxidized by sulphuric acid giving iodine gas, and sulfur dioxide and water is produced. Now we are going to discuss the confirmatory test. The salt solution plus silver nitrate solution. The produced precipitate is yellow precipitate of silver iodide, which is formed and insoluble in concentrated ammonia solution, as the following animation show. Here as shown on the screen, on adding the silver nitrate on the sodium iodide solution, we will find the reaction takes place giving yellow precipitate of silver iodide that shown on the screen. Here the equation of the reaction, sodium iodide plus silver nitrate, it gives sodium nitrate and silver iodide is precipitate. Now we are going to discuss the last anion of the sulfuric acid group, which is nitrate radical NO3 -1. The main test here, the unknown solid salt plus concentrated sulfuric acid plus heat. Here the produced gas is brown vapor of nitrogen dioxide gas that evolves due to decomposition of the produced nitric acid, which increases by adding excess copper turning, as the following animation show. As the animation shows, the sulfuric acid is added on the nitrate salt. It gives reddish brown fumes, and on adding copper turning, the reddish brown fumes has increased. So the equation of the reaction here, sodium nitrate plus sulfuric acid, it gives the sodium sulfate and nitric acid. And this nitric acid decomposed by heating, giving reddish brown fumes of nitrogen dioxide gas, and water and oxygen are produced. Then on adding copper turning on the nitric acid, here the reaction proceeds giving nitrogen dioxide gas, which is reddish brown fumes, and also copper nitrate and water as shown on the screen. Now we are going to discuss the confirmatory test. Here the salt solution plus freshly prepared concentrated solution of iron 2 sulfate. Then add few drops of sulfuric acid on the internal walls of the tube. The observation here is a brown or black ring appears at interface of the tube and disappears by shaking or heating. So here sodium nitrate plus iron 2 sulfate plus sulfuric acid, it gives here iron 3 sulfate and sodium sulfate and nitric oxide gas and water vapor. Here, my dear student, the nitric oxide gas reacts with iron 2 sulfate, forming the black ring compound, which is FeSO4NO. Now we have give reason in this point. Hydrochloric acid is not used to detect the anions of the group of sulfuric acid, because hydrochloric acid is less stable than the acid of these anions, so doesn't react with their salts. Another give reason in this point, concentrated sulfuric acid reacts with the salts of anions of hydrochloric acid group, because the sulfuric acid is more stable than the acids of these anions, so react with their salts. Now we are going to discuss the anions of barium chloride solution, which include the following anions: phosphate anion PO4 -3 and sulfate SO4 -2 as shown on the screen. We have given reason this point. Both of hydrochloric acid and sulfuric acid are not used to detect the phosphate and sulfate anion, because both of hydrochloric acid and sulfuric acid are less stable than the acids of these anions, so they don't react with their salts. Now, my dear students, the salt solution of these anions of that group, which is phosphate and sulfate, give a colored precipitate with barium chloride solution. So we are going to discuss these reactions. First, we are going to discuss the phosphate anion BO4 -3 as shown on the screen. The main test is the salt solution plus barium chloride solution. Here the produced precipitate is white precipitate of barium phosphate that's soluble in dilute hydrochloric acid. As the equation proceeds on the screen, sodium phosphate plus barium chloride, it gives sodium chloride and white precipitate of barium phosphate. Now we are going to discuss the confirmatory test. Here, the salt solution plus silver nitrate solution. The produced precipitate is yellow precipitate of silver phosphate, which is soluble in ammonia solution and in nitric acid. My dear student, you have to remember that silver nitrate with iodide salt give also yellow precipitate, but it insoluble in ammonia solution, while the silver nitrate with phosphate salt give yellow precipitate, which is soluble in ammonia solution. As the equation proceeds on the screen, sodium phosphate plus silver nitrate, it gives sodium nitrate and silver phosphate, which is yellow precipitate. The second radical, my dear student, in the barium chloride group is sulfate radical, has symbol SO4 -2. The main test, the salt solution plus barium chloride solution, it gives white precipitate of barium sulfate, which is insoluble in dilute hydrochloric acid. As the equation proceeds on the screen, sodium sulfate plus barium chloride solution, it gives sodium chloride aqueous and white precipitate of barium sulfate, as the following animation will show. If we add the barium chloride solution to the phosphate ion or sulfate ion, it gives white precipitate that is soluble in dilute acid if it is phosphate, but it is insoluble in dilute acid when it is sulfate ion. The confirmatory test, here the salt solution plus lead 2 acetate solution, it gives white precipitate of barium sulfate. As the equation proceeds on the screen, sodium sulfate plus lead acetate, it gives white precipitate of lead sulfate and aqueous solution of sodium acetate is formed. My dear students, if we have a question here, how to differentiate between here sodium carbonate and sodium bicarbonate. Here the experiment, the salt solution plus magnesium sulfate solution. Here the observation, if white precipitate is formed on cold, so it is sodium carbonate. As the equation proceeds on the screen, sodium carbonate plus magnesium sulfate, it gives sodium sulfate and magnesium carbonate, which is insoluble in water, giving white precipitate on cold. But if white precipitate is formed after heating, it will be sodium bicarbonate. As the equation proceeds, here sodium bicarbonate reacts with magnesium sulfate. Here it gives sodium sulfate and magnesium bicarbonate. All of them are soluble in water. On heating the solution, it gives white precipitate of magnesium carbonate, and the carbon dioxide and water is produced, as the following animation will show. Here is a solution of carbonate, and adding magnesium sulfate, it gives white precipitate is formed on cold. Here, my dear student, if we use another solution and add magnesium sulfate solution over it, it doesn't form white precipitate. But on heating, it gives white precipitate after heating, so it is bicarbonate salt. My dear student, another how to differentiate sodium nitrite and sodium nitrate. Here, by adding the salt solution to solution of potassium permanganate, which is acidified with concentrated sulfuric acid, the solution, the violet color of potassium permanganate disappears, so the salt is nitrite. But when the violet color remains, it will be nitrate. As the equation proceeds on the screen, the sodium nitrite plus potassium permanganate plus sulfuric acid, here it gives sodium nitrate, potassium sulfate, and the manganese sulfate and water. So the nitrite removes the color of the potassium permanganate, as the potassium permanganate is oxidizing agent. So it changes the nitrite radical into nitrate radical. Another differentiate, my dear student, sodium phosphate and sodium sulfate. Here, if the salt solution plus barium chloride solution, if the observation here white precipitate is formed soluble in dilute hydrochloric acid, so it is sodium phosphate. As the equation proceeds on the screen, sodium phosphate plus barium chloride, it gives barium phosphate and sodium chloride. Here the barium phosphate is white precipitate that soluble in dilute hydrochloric acid. But if the white precipitate is formed but insoluble in dilute acid, so it is sodium sulfate. Here the equation proceeds on the screen, sodium sulfate plus barium chloride solution, it gives white precipitate of barium sulfate and sodium chloride solution is produced. Now we are going to discuss some questions, my dear student. The first type of questions is choose the correct answer. Salt solution plus silver nitrate solution, it produces yellow precipitate that insoluble in concentrated ammonia solution. Is it iodide salt or nitrate salt or chloride salt or bromide salt? If you think about it, my dear student, yes, it will be iodide salt. Next one, the solid salt plus concentrated sulfuric acid gives orange-red fumes that turns paper wetted with starch to yellow. Is it chloride salt or iodide salt or bromide salt or nitrate salt? If you think about it, yes, it will be bromide salt. Next question, solid salt plus concentrated sulfuric acid gives gas, forms white fumes with paper wetted with ammonia solution. Is it bromide salt, chloride salt, iodide salt or nitrate salt? If you think about it, yes, it will be chloride salt. Next one, the solid salt plus concentrated sulfuric acid gives violet fumes that turns paper wetted with starch to blue. Is it chloride salt, bromide salt, nitrate salt, iodide salt? If you think about it, my dear student, it will be iodide salt. Next one, solid salt plus hot concentrated sulfuric acid gives brown fumes that increase by adding excess copper turning. Is it nitrate salt, chloride salt, bromide salt, iodide salt? Yes, the answer it will be nitrate salt. Next one, the salt solution plus silver nitrate solution produce white precipitate turns violet in sunlight. Is it iodide salt, nitrate salt, bromide salt, chloride salt? If you think about it, yes, the answer it will be chloride salt. Next one, the salt solution plus silver nitrate solution produce white yellow precipitate. Is it bromide salt, nitrate salt, chloride salt, iodide salt? Yes, if you think about it, yes, it will be bromide salt. Next one, the salt solution plus barium chloride solution produce white precipitate insoluble in acids. Is it phosphate salt, sulfate salt, nitrate salt, or nitrite salt? If you think about it, yes, it will be sulfate salt. Next one, the salt solution plus lead 2 acetate solution produce white precipitate. Is it phosphate salt, nitrate salt, sulfide salt, or sulfate salt? If you think about it, my dear student, it will be sulfate salt. Next one, the salt solution plus barium chloride solution produce white precipitate soluble in acids. Is it phosphate, or sulfate, or nitrate, or nitrite? If you think about it, my dear student, yes, it will be phosphate salt. Next one, the salt solution plus silver nitrate solution produce yellow precipitate that's soluble in concentrated ammonia solution. Is it iodide salt, nitrate salt, chloride salt, phosphate salt? Yes, if you think about it, my dear student, yes, it will be phosphate salt. Now, my dear student, we discuss another type of question which is give reason for. Hydrochloric acid is used to detect the anions carbonate anion, bicarbonate anion, sulfite anion, sulfide anion, thiosulfate anion, and nitrite anion. If you think about it, yes, the answer it will be because hydrochloric acid is more stable than the acids of these anions, so when it reacts with their salts, it releases their less stable acid in form of gas that can be detected by suitable test. Next one, sulphuric acid is used to detect the anions chloride, bromide, iodide, nitrite. If you think about it, my dear student, yes, the answer will be because the sulphuric acid is more stable than the acid of this anion, so when it reacts with their salts, it releases their less stable acids in form of gas that can be detected by suitable test. Another point, both of hydrochloric acid and sulphuric acid are not used to detect phosphate and sulfate anion because both of hydrochloric acid and sulphuric acid are less stable than the acids of these anions, so don't react with their salts. Next type of questions, write the scientific term. It is the identification of the constituents of the substance, if it is pure or mixture. If you think about it, yes, it will be qualitative analysis. Next point, it is a determination of the ratio or the percentage of